Okay, hello, welcome to week 15, chapter 11, lesson 6, counting principles, permutations, and combination. At the end of this lesson, you should be able to use a fundamental counting principle, use permutation formula, and also you should be able to distinguish between permutation and combination formula. And finally, we're going to apply the combination formula. Now, let's see the content of the lesson. So in this week, we are going to discuss about what is the fundamental counting principle and its application. And then we are going to discuss about permutations. We'll see when we are going to use a permutation and when we are going to use combination. We'll distinguish between the two. Okay, so this is about the lesson content. And at the end of each solved example, you should exercise from your textbook. Okay, now let's begin our lesson with the fundamental counting principle. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So this is a fundamental counting principle. Now let's see example regarding the fundamental counting principle. Example 1. Options in planning a course schedule. Next semester, you are planning to take three courses: Math, English, and Humanities. Based on time blocks and highly recommended professors, there are 8 sections of Math, 5 of English, and 4 of Humanities that you find suitable. Assuming no scheduling conflict, how many different three courses schedules are possible? So here you are asked to find the number of ways that you can register for the courses. You have three courses: Math, English, and Humanities. And for each courses, there are different sections. For example, for Math, you have three sections, for English, five, and for Humanities, four. So what you are going to do, you are going to apply the fundamental counting principle. So you have 8 ways that you can apply for math, you have 5 ways for English, and 4 ways for humanities. So you are going to use the fundamental counting principle, which means 8 times 5 times 4, which is going to be 160. So you have 160 different three-course schedules are possible. This example 1. Let's go to example 2. Multiple choice test. You are taking a multiple choice test that has 10 questions. Each of the questions have 4 answer choices, with one correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the questions? So each question has 4 choices. So you have 4 ways of answering each question. And the total number of questions is 10. Therefore, the first question you have 4 ways, so 4 times. The second one, the same, 4 ways to answer question 2. So 4 times 4 times. The third one is the same, 4 ways. So 4 times 4 times 4 times. So you are going to multiply 4, each 4, 10 times. So you will get 4 to the power of 10. So you have 4 to the power of 10 ways of answering the question. Okay, so which is around 1,048,576 way of answering the 10 questions with 4 choices. So this example 2. So in example 1 and example 2, we apply the fundamental counting principle. That means, in general, for example, if you have m ways of choosing an item, and if you are going to choose another item, let's say this item has n ways, so the total ways that you can choose these two different items will be m times n. So this is a general summary for the fundamental counting principle. Okay, Now let's go to example 3, telephone numbers in the United States. Telephone numbers in the United States begin with 3 digits area code followed by 7 digits local telephone numbers. Area codes and local telephone numbers cannot begin with 0 or 1. The question is how many different telephone numbers are possible? So in the United States, you have two ways. There are two things that are included in the telephone number. The first one is area code, and the next one is the telephone number. The telephone number contains 7 digits, and the area code it has 3 digits. But one thing that you should focus: the area code and the local telephone number cannot begin with 0 or 1. Therefore, for example, for the area code, the first digit has to be 8. So there are 8 ways that we can uh, have in the first digit of the area code because 0 or 1 is not included. But for the other 2 digits, you have 10 ways. So the number of ways that you can have the area code will be 8 times 10 times 10. For the same is true for the telephone. There are 7 digits for the local telephone numbers, and the first digit of the local telephone number cannot contain 0 or 1. Therefore, you have how many ways that you can have for the first digit of the local telephone number? 8. But for the other digits, it will be 10. Okay, so the total number of telephone number that you can have will be 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10, which is about 6.4 billion telephone numbers are available in the United States. So example 1, 2, and 3 deal about the fundamental counting principle. Now let's go to permutations. An order arrangement of items that occur when no item is used more than once, and the order of arrangement makes sense. In this case, we are going to use permutation. So to find the number of possible permutation, if r items are taken from n items, we are going to use this formula. So the number of permutations taking r items from n items will be n factorials over n minus r factorials. So here in permutation, arrangement or order matters. Okay, order matters when you arrange an item. So this is a very important point. Now let's go to example 4. Using the formula for permutation, you and 19 of your friends have decided to form an internet marketing consulting firm. So here the total number of people are 20 because 19 plus 1, which is including you, there are 20 people. So the group needs to choose 3 officers, a CEO, operating manager, and a treasurer. So you are going to select or you are going to arrange or order 3 people out of 20. In how many ways can those officials be filled? Here, the responsibility of the officers is different, therefore order matter. Therefore, we are going to use a permutation. So you are going to evaluate 20p3. Okay, 20p3 because there are 20 people. Out of 20 people, you are going to order or arrange 3 officers, and the 3 officers they have different responsibility. So you are going to use a permutation. So it will be 20 factorial over 20 minus 3 factorial. So simplify it will be 20 factorial over 70 factorial, which will be 20 times 19 times 18. Then you are going to choose 6,840. So you can group in 6,840 ways. Example 5. Using the formula for permutation again, you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books assuming the order of the books makes a difference to you. So here again, since order matters, therefore you are going to use a permutation. So how many items do you have in total? 7. So you are going to arrange these 7 books in a shelf. So because you consider the order of the books, so again you are going to use a permutation, okay? So which is 7 7, which is 7 factorial over 7 minus 7 factorial. 7 minus 7, 0, 0 factorial is 1. So 7 factorial over 1 factorial, which is 7 factorial. So it will be 5040. So you can arrange your 7 books in 5040 ways. Now this is about permutation. Now let's go to combination. Group of items taken without regard their order. Okay, in combination, order doesn't matter. So we are going to use a combination. Number of possible combination. If r items are taken from n items, then it will be NCR, which is going to be equal to n factorial over r factorial into n minus r factorial. So this is the formula for combination. Now let's see example 6. In example 6, you are asked to distinguish between permutation and combination. For each of the following problems, determine whether the problem is one involving permutations or combination. It's not necessary to solve the problem, okay? 6 students are running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes president. The second highest vote getter becomes vice president. And the student who gets the third largest number of votes will be treasurer. How many different outcomes are possible for these 3 positions? So here in this case, as you can see, order definitely matters, okay? President, vice president, and treasurer, they have different responsibility. So in case of A, we are going to use a permutation. So students are choosing 3 student government officers from 6 candidates. The order in which the officers are chosen makes a difference because of each officer is different. Therefore, order matters, so it will be a permutation. For B, 6 people are on the board of supervisor for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? So here definitely a 3-person committee is to be formed from 6-person board of supervisor. The order in which the 3 people are selected does not matter because they are not filling different roles of committee. It's not like that of A. Okay, nothing is mentioned the 3-person committee about their responsibility. Therefore, definitely it will be combination because order doesn't make a sense. So the problem is involving combination. Let's go to C. Baskin Robbins offers 31 different flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? A 3-scoop bowl of 3 different flavors is to be formed from Baskin Robbins' 31 flavors. The order in which the 3 scoops of ice cream are put in the bowl is irrelevant. A bowl with chocolate, vanilla, or strawberry is exactly the same as a bowl with vanilla, strawberry, and chocolate. The flavor will be the same. So different ordering doesn't change things, so the problem is involving a combination. So this is a way that we can distinguish permutation and combination, okay, between permutation and combination. So one thing that you should always remember, in permutation, order makes sense, but in case of combination, order doesn't matter. So this is example 6. Now let's go to example 7. In example 7, using a formula for combination, a 3-person committee is needed to study ways of improving public transportation. how many committees could be formed from the 8 people on the board of the provider. So here you are going to choose 3-person committee where their responsibility is not mentioned. So definitely you are just simply selecting. So the problem is involving combination. So you are going to choose 3 people out of 8. Therefore, you are going to use the formula 8 the 3, which is 8 factorial over 8 factorial uh, into 8 minus 3 factorial. So it will be 56. So we are going to discuss, this will be the last example. I will stop here, but we will have more practice on our live discussion, and also I will post some question on Schoology. So please be active, and if you have any question, you can ask me on Schoology or you can ask me on our live discussion. So I will stop the discussion for the video now. Thank you very much and goodbye.